Hi, Bill.
Hi, Sherry.
This is so exciting to have you here. I've been wanting to interview you and find out some of the things that you know about climate.
Yes,
I've heard you talk about sky brightening, which is a concept that might be new for some people, but it's
yes.
a very interesting concept. To begin, I'd like to say a little bit about your background, and maybe you can add to it. I have a number of pages here about you, but you've done so much. I won't go into all of it, or we take up our whole 30 minutes right here with your introduction. But basically, what I'm learning about you is that you have chaired a number of committees, a number of organizations internationally and within the United States, working on solutions, practical and effective solutions to climate issues.
Yes, and mostly I have come to that through work on life cycle environmental assessment, on making the best science-based methodologies for determining the true environmental impacts of products and services, considering their whole life cycle, cradle to grave. And one of the indicators of environmental performance is climate. What effects do products and services have on climate? And so I kind of backed into climate work from the life cycle assessment arena.
Okay, and you started out with, did you start out with the government?
Yes, I did. I did a 30-year career in federal service and mostly worked for a couple of different construction agencies, Bureau of Reclamation, Western Area Power Administration. And my work was involved in trying to minimize the environmental impacts of those activities.
And after you finished with your work with the government, you went on to private industry?
I became a consultant, an environmental consultant. And as you may know, a consultant is somebody who borrows your watch to tell you what time it is. And so I've worked for a number of different clients, and mostly now I'm doing volunteer work in the development of national and international standards for life cycle environmental assessment, and a little bit also on climate accounting protocols.
Okay, and all of this means that this gentleman has a lot of information that can help us sort through and figure out what's going on with our climate, because we hear a lot of diverse opinions about climate change, warming, what's going on with the air that we breathe, and are we going to be around for a while? So we also have a little bit of information that we want to share about some of the alternative methods that we can power our world with, but we're going to just go into that a little bit because we're going to have part one of the short-term solutions to some of these issues, and then part two would be a long-term solution. So stay with us. If you go through this first video, be sure to go to the next one, which will be the long-term. Both are really important, it sounds like. So let's begin with the whole idea of this climate of ours. Are we really warming, or are we cooling, or what is your opinion now that you've researched this?
Good place to start, Sherry. And yes, the planet is warming up. Global mean temperature has risen about 0.7 7/10 of a degree centigrade in the last couple of decades. And so that trend is actually accelerating. We expect with ups and downs, but it is increasing. Global mean temperatures are increasing, and we expect them to continue to do so unless we do some kind of intervention. So the good news is there are interventions that we can use, and we can actually reset climate to the levels that we experienced before the industrial age. We could reset climate to 1750 levels. We have the technology and the ability to do that. And we can do that without environmental impacts. and we can also do it without breaking the piggy bank. We can do it economically. So that's what we'll talk about today.
That's good. That's the good news. I wanted to bring out some hope in this age of despair where there's so much to worry about. I think people need to see that we do have solutions and that you've been working on them nationally and internationally. And we would like to hear more about what they are.
Okay. So a little bit of foundational information for this presentation is that the short-term solution will not involve reducing our emissions of greenhouse gases. And I know this sounds like heresy because the Paris Accords, the climate accords, are all focused on reducing our emissions of carbon dioxide being a principal greenhouse gas, a gas that traps heat in the atmosphere. So when you actually use the latest climate accounting protocols, which have been developed and published in the latest report from the Inter-governmental panel on climate change, what you learn is that if we were to completely stop emissions of CO2 and other greenhouse gases today, there is already enough in the atmosphere that we will continue to warm the planet. It's like if you put a pot of tap water on the stove, turn the fire on underneath it, you can keep your finger in the pot of water for some period of time before it gets too hot. The temperature of the water in the pot is analogous to the temperature of our atmosphere and our planet. The flame under the pot is analogous to the greenhouse gases that are already in the atmosphere. Total anthropogenic, total human emissions of carbon dioxide are annually about 2% of what is already in the atmosphere. And that stuff has a half-life of 150 years. So it's already up there trapping heat every day. And it will continue to do so until the concentration comes back down. So that's why I say, even if we were to stop emitting any more CO2, what we emit every year is a drop in the bucket compared to what's already up there. So we need a different approach to cooling off the planet. And that is, we have to start reflecting more sunlight back to space than we do now. It's not sunlight that heats up the planet. It's not solar radiation, it's Earth radiation. So sunlight comes in, reaches the surface of the planet, is absorbed, and it's re-emitted at a different wavelength, a longer wavelength. It's re-emitted as heat. And the greenhouse gases that we have concentrated in our atmosphere are like a blanket that catch that heat and trap it so it can't leave the atmosphere. It doesn't leave the planet. So a way to reduce the amount of heat that we trap is to reflect a certain amount of sunlight back to space. Don't even allow it to hit the surface of the planet. Let's send it back out before it can heat the place up. And there's a great way to do that. Now, that has happened in the past. When, for example, when Krakatoa, the volcano, erupted in 1883, it spewed out a lot of stuff, a lot of ash, a lot of rocks. But one of the things that came out of Krakatoa was sulfate aerosols. And those look like a white haze. And there have been some concerns in recent years about the white haze over the Grand Canyon. People can't see some days all the way across the Grand Canyon, and it turns out that's because of sulfate aerosols in the air. And those are emitted by some coal-fired power plants in the southwestern US. And eventually they drop out in the airshed somewhere, but Grand Canyon is close enough to the sources that you still see that white haze. When Krakatoa blew up, it put out a huge amount of sulfate aerosols, so much so it cooled the planet off to the point that in the following January, people were ice skating on the Thames River in London. Never had that happen before. Okay, so that was an enormous event. There were crop failures globally. So what we intend to do is not put up sulfate aerosols because those have human health effects. They have respiratory effects on human beings. They can also acidify aquatic ecosystems to the point where they're no longer viable. So what we intend to do is put up some salt in the air over the deep oceans. If you've ever been to the beach on a windy day and looked out across the ocean, you've seen a white haze. And that's just droplets of water that are blown off the waves into the air. The water evaporates and leaves little particles of salt. And that's where the white haze comes from. It is a naturally occurring process. That salt ultimately drops back into the water. It's reabsorbed, redissolved. There's an unlimited supply of it. So our solution is to have autonomous vessels fitted with devices that suck up seawater, put it out through a nozzle in a spray, atomize it. The water evaporates, and each of these vessels leaves behind a plume of white haze that reflects sunlight back to space before it has a chance to reach the surface and warm up the planet.
That sounds like a simple solution. Well, fairly simple. And that's what you call sky brightening?
Yes, sky brightening.
Okay.
And so I want to make a distinction between sky brightening and cloud brightening, which has been proposed as a solution to climate. So it is possible to intensify cloud formation and produce more clouds, that clouds also reflect sunlight back to space. They're white. You can see if you look down from an airplane at clouds, it's a bright surface that's reflecting sunlight back to space. But there are side effects from cloud brightening, from enhancing clouds, and you can imagine what those might be. Tornadoes, hurricanes, increased rainfall, torrential rainfall in certain areas, droughts in other areas. So we feel that there are too many unknown impacts for us to consider cloud brightening as a viable alternative to climate change. As opposed to cloud brightening, sky brightening done through sea salt is already naturally occurring process. It is easy to control because those particles will settle out in a known period of time. We would do it over deep oceans in the tropics. It would not reach human inhabited areas. And in fact, if one were on a vessel right at the edge of one of these plumes that I'm talking about, one of these salt plumes, and one looked to the left underneath this plume and compared it to underneath to the right where there is no plume, you would not be able to tell the difference in brightness. You could not see the difference in brightness. And it turns out that it takes only a small change in what we call radiative forcing, the forcing that is created by solar radiation striking the Earth, changing wavelengths, being reabsorbed as heat. The global average for solar radiative forcing, solar radiation, is about 370 watts per square meter. If we could reduce the global average by 2 watts per square meter, we could reset our climate to pre-industrial levels. So that's why this would not be, there would not be a visual impact from it. There would certainly not be an ecological impact because it's a naturally occurring process using an unlimited resource, seawater.
Of course, the natural question would be, well, why aren't we already doing this? What will it take to put this into effect?
So we already have a group working on this technology, and we have an engineer, mechanical engineer at the University of Washington. There's also an eminent member of the computer community in California who was involved in the first development of laser printers. All that to say, he is an expert on nozzles and how to atomize, particleize liquids that are sprayed through nozzles. So what we need to do, and we've already received a $1 million grant from the Gates Foundation. God bless the Gates Foundation for being so forward-looking and committed to environmental protection and saving this planet from runaway warming. We need about another $30 million to develop a demonstration project so we can prove that you actually can deploy an autonomous vessel controlled by satellites that will put up a salt plume and be able to measure the difference that it's creating. And so once we can prove that, our initial estimates, and these are rough, is that we could actually reset global temperatures to pre-industrial levels for about $30 billion a year. It'd be more than I could afford. The demonstration project is more than I can afford, but it's a drop in the bucket to our federal government.
Tell us why we need to reset our climate to the pre-industrial age. What would happen if we didn't do this? I mean, what's ahead for us? Because we're going to warm. The planet is warming, but what is that? I mean, we know that the low-lying areas could flood because the water is warming, and there could be kind of the end of coastal cities as we know it. But what else can you tell us about what would happen if we keep continuing in the direction we're going?
Well, so many different impacts. In the zones where we live in the United States, this temperate zone, agriculture will suffer. Our food production will decline as we see increasing temperatures and probably increased droughts. It's likely that there will be, we might not see a decline in the amount of precipitation, but we may get it all at once in huge storms that are damaging. And then we may have long periods of drought in between. But the biggest effects will be in the tropics, where you're going to get daily temperatures in the 130-degree range, maybe up to 140. And according to the latest IPCC reports, we have we believe about a decade to do something about this, to have some kind of intervention. So if we don't, and the tropics become uninhabitable, think about what happened with 1 million or 2 climate refugees from the Middle East. What happened in Europe? It has been hugely destabilizing. Imagine now 100 million climate refugees from the tropics wanting to go north and south all over the world. It'd be a huge challenge for most countries, certainly for ours. There's a tipping point that we have not reached, but we are approaching it. And the tipping point is when the planet warms up enough that the methane that is currently stored in Arctic tundra and in nearshore continental shelf sediments, when that warms up enough and becomes released, that methane, which by the way has an ability to trap heat 100 times greater than CO2. A molecule of methane, natural gas, traps heat 100 times more efficiently than a molecule of CO2. If all of that methane comes out, that's game over. We will have runaway climate warming, and we will not likely have the ability to prevent it. So we have a window of about a decade, and we can, through sky brightening, we can bring temperatures down. And some people say, well, what if you go too far? What if we cool it off and precipitate another ice age? Well, the beauty of this technology is that we can titrate it. If we begin seeing that we are cooling things off too much, we emit less salt into the atmosphere. Very simple. That stuff drops out within hours. So a quick feedback loop, and we can titrate it exactly to what we need.
How can we be involved in helping to present this to the people that need to hear it?
We've been attempting to get this message into Congress. What we'd like, and our ask is $30 million to do a demonstration project to show that it actually works, and also to refine the nozzle technology. nobody's ever needed to atomize sea salt before. And so we need the most efficient nozzle that we can deploy. About $30 million. And so if you call your congressman or write to your congressman and Congress representative and say to him or her, we need this $30 million for a demonstration project on sky brightening. It is cheap, it's impact-free, and it will save us from either runaway warming or the Paris Accords, which their plan, and by the way, the US has withdrawn from the Paris Accords, which is probably the smart thing to do. Because as I said before, even if we reduce our emissions to zero, we still have runaway warming. Yes, we need to do something about our emissions in the long term. That'll be our next segment. Although the Paris Accords were well-meaning, and yes, we need to reduce our greenhouse gas emissions in the long term, they will not save us in the short term. We need to deploy what we call negative forcers, negative radiative forcers that reduce the amount of heat that's being trapped on the planet. And we need to do that pretty soon. As I was telling Sherry earlier, it's analogous to driving your car toward a stop sign. You see the stop sign, and as soon as you see it, if you take your foot off the gas and put it on the brake, you never have to brake very hard. But if you keep your foot on the gas until you get very close, then you have to really drastically press on your brake pedal. Same thing with climate intervention. If we can get started now doing sky brightening, it won't take very much. If we wait too long, we have runaway warming and we have lost our opportunity to do something to prevent it. So the sooner we start, the more effective it will be and the less drastic the change will be.
Okay, that's real important. What comes to my mind, of course, is this constant argument we have with our government and those forces that keep saying there is no climate change happening, there's no warming, and even on a cold day, we'll hear somebody on the internet saying, well, what about global warming? This is like obviously not warming, this is cooling. When we have factions that are dividing us and saying it's not true, factions that are part of our governing body, and what it does is it leaves a certain segment of society confused and in disbelief over any of this being true. And it seems like we have to somehow explain and prove to the public that we need to take action. Something needs to be done, because until people get it, there won't be much of a movement. There are those few legislators who are now trying to work with the Green Project. What is it called? From Alexandra Cortez?
The Green New Deal.
The Green New Deal. Now, are these people to approach?
I think these are people who have expressed an interest in improving our environment and preventing climate change. So as far as that goes, I think, yes, those are people who could be approached. Whether the Green New Deal itself, as it's exactly been presented, is viable, one could debate that. But I think that at least it expresses an intention that our government take these impending threats seriously and do something to intervene.
Yeah, she certainly has the attention of a lot of people now. It sounds like it's a matter of education to get the folks that she gathers together on board with what's really going on and scientifically what can be done, or at least what could be tested.
And back to your observation that there are people who don't believe that the climate is changing, or people who believe that what we're experiencing in terms of warming is actually a natural trend. The best studies I've seen show that there is a natural signal in the temperature increase that we have measured and is indisputable. The planet is warming up, but there is also an anthropogenic signal, a human-caused signal. and that's from our emissions of greenhouse pollutants. And so I think we have a responsibility to do something to counteract that. And as I said, maybe at least twice, it doesn't do enough in the short term to stop emitting greenhouse gases. Yes, we must do it in the long term. In the short term, we have to take action to reduce the heat input to our planet through negative forcing, through reflecting sunlight back to space. Seems to be about our only option.
I think some people have had the idea that no matter what we do, I've heard people say this, then all of a sudden a volcano goes off and all this ash and dust is in the air, and which really changes a lot of our atmosphere. But you explained earlier how this is a different effect and how this doesn't really contribute to global warming, but in fact can be a positive force.
Well, so first of all, yes, these volcanoes, as we described earlier, can cool off the planet. Depending on the size of the volcano, the size of the eruption, they can have significant cooling effects. Probably praying for a volcano is not going to be a viable strategy for preventing runaway warming. If it happens, we'll deal with whatever happens. And the beauty of the intervention that we are proposing through sky brightening is if we do have a big volcano pop off and it does cool the planet, we can stop putting up sea salt until those sulfate aerosols drop out of the atmosphere. And then if we need to, we can go back to sea salt brightening.
How would we like to finish this up? And in conclusion, what could you give us that we can do in the short term for solutions for our climate issues?
Sure. So in conclusion, we have an opportunity in the next decade or so to prevent runaway climate change and prevent all of the social and economic and human health problems that would come with that. And those are significant. And also sea level rise, which Sherry mentioned. There's now a term called climate adaptation that people are promoting as something, as a response to climate change. It's just a fancy word for moving all of our coastal cities inland at enormous expense to society. And we don't need to do that. So a simple solution is through the use of sea salt, which is here in enormous abundance and is already getting blown into the atmosphere through natural processes. We just increase it a little bit until we have stopped the warming and in fact begun to cool the planet back to levels which we know are safe and healthy for the planet and for humanity.
Great. And I'll put a little bulletin at the bottom about calling the people that need to be told about some of these things. That they have so many other things that they're dealing with. It's hard for them to focus on one thing or another. But if we really get to the place where we get that our planet is in dire straits, that something needs to be done now, perhaps those of you that are listening to this or watching this can take some steps and call some of the people that we recommend to make a difference.
And so, you can make a difference.
That's good. That's good to know. We'll leave you with that.
And in fact, just knowing that a solution is available, it is inexpensive and highly effective, and just envisioning us bringing about that solution, I think will do more than you can imagine toward making it a reality.
Oh, thank you for saying that, because many videos in the series is about what we're thinking, what we're saying, what we're doing does make a change, and that we have to listen to what we're saying and know that we can produce some positive results with the right thinking and acting and speaking in particular. So thank you for that, Bill. And
thanks, Sherry.
Yeah.